Everybody. Today we are talking about Cambridge Checkpoint Year 9 Start. Unit 1 Integers and Power and Roots. So we will start by directed number and square roots and cube roots, indices, and work with. So for the directed number, let's say that we have the number started from 0. If it's positive number, it will start from 0 in the right hand side. So if we consider that the negative number is in the opposite direction of positive number, so it will start from 0 to the left hand side. So think of the number line started from 0, moving 3 to the right, then 5 to the left. It's same as moving 2 to the left. So this is a directed number. So we have some rules to work with this directed number. Rule number 1, we are talking about sign. So if it's positive, that means positive and we no need to write it. If it's negative, that means negative number and we should write it. So for our rules, let's start by addition and subtraction. For the addition, if we adding a negative value to positive value, let's say that 5 plus minus 3 it equal same meaning for 5 minus 3, so it will be 2. So for subtracted negative it will mean adding positive. 5 minus 5, or sorry, 5 minus 3 is equal to 5 plus 3, so that means that the value will be 8. So let's say example number 3, minus 5 plus minus 0.3, it equal to minus 5 minus 0.3. It will be minus 5.3. So for the multiplication and the division, so it's a simple rule. Same signs, it meaning positive answer. Different signs, it mean negative answer. That means in case of multiplication and division, let's say that we are multiply two different signs, like example number B. Minus 2 multiplied by 3 is equal to negative answer, negative 6. But for the same signs, like minus 3 multiplied by minus 3, supposed to be positive 6. And positive 3 multiplied by positive 3 is equal to positive 6. Okay? Next lesson, which is square roots and cube roots. So first of all, we should be able to recognize the square of whole numbers up to 20 by 20 and the cube for whole numbers up to 10 by 10. So in the right hand side you will find the table containing a number from 1 to 20 and the square values for all of these integer numbers and the cube value for all of these integer numbers. So we need to save this one in our memory. So let's start by example. Read the statement on the right and write the similar statement each root. So we have similar statement like square root for 8 bigger than 2 less than 3. So the square root for 20. If we look at the right hand side for the table, so 20 will be more than 4 and less than 5. The square root for 248 is more than 15 less than 16. In between 225 to 256. The square root for 314 supposed to be in between 289 to 324. Supposed to be from 17 to 18. The square value for 83.4 supposed to be bigger than 9, less than 10. The square root for 157 is bigger than 12 less than 30. So next example or next exercise related to square root and cube root. Read the statement on the right hand side and write down the similar statement to each root. So the cube root for 1200 bigger than 10 less than 12. It's in between the value of 1000 to 1331. So the cube root for 100, if we look at the table, supposed to be in between 64 for 4 and 125 for 5. It will be bigger than 4, less than 5. The cube root for 222 supposed to be in between 216 for 6 and 343. So the cube root for 825 bigger than 9, less than 10. The cube root for 326 bigger than 6, less than 7. And the cube root for 58.8, it's supposed to be in between 27 to 64, more than 3, less than 4. So shows that the cube root for 125 is less than half of the square root for 125. So if we look at the table, 125 for the square root will be 121 will be 11. So the square root for 125 is more than 11. If we look at the cubic root for 125, it's 5. So the result is cube root for 125 equal 5, while square root for 125 is more than 11. So it's more than half. Less than half or more than double or duplicated. Next lesson, which is indices. So if we write 3 to the power 4, which is on left hand side, it called 3 to power 4, and the 4 is called the index. So 3 to power 4 is equal to 3 multiplied by 3 multiplied by 3 multiplied by 3. That means I am multiplying 3 4 times together, and the result will be 81. So negative power for any positive integer are fraction. That means if it's 3 to the power minus 4, will be 1 over 3 to power 4. That means 1 over 81. Any positive integer to the power 0 is equal to 1. 3 to power 0 equal 1. 7 to power 0 equal 1. Exercise is 1.3. Write each number as a fraction. 5 to the power minus 1, 5 to the power minus 2, and 5 to the power minus 3, 5 to the power minus 4. So 5 to the power minus 1 is equal to 1 over 5. 5 to the power minus 2 is equal 1 to 5 to the power 2, which is 1 to 25. 5 to the power minus 3 is equal to 1 to 125. 5 to the power minus 4, 1 over 625. And on the right hand side, write each number as a fraction or integer. 7 to the power 2 is equal to 49. 7 to the power minus 2 is equal to 1 over 49. 7 to the power minus 1 is equal 1 over 7. 7 to the power 0 is equal 1 with the same rule above. 7 to the power 3 is equal 1 over 7 to the power 7 to the power 3 is equal 343. The next lesson, which is working with indices. Rule number 1 for multiplication. Let's say we have the same integer number which called a, and it have index m, and I need to multiply it to a index n. So in this case, in case of multiplication for the number adding the indices, that means I am going to put the same a and for the index I will add m plus n. So on the right hand side we will find the example. 9 multiplied by 9 is equal 81. So 9 is equal to 3 to the power 2. Multiplied by 3 to the power 2 is equal to 3 to the power 4, which is 3 multiplied by 3 multiplied by 3 multiplied by 3. And it will end it by 81. 4 multiplied by 8 is equal to 32. So let's say that 4 is 2 to the power 2 and 8 is 2 to the power 3. So in this case, it will be 2 to the power 5. I am adding 2 to 3 and the result will be 32. So rule number 2 for the division. To divide the power of number, subtract the indices. That means a to the power m divided by a to the power n will end it to give me the result a to the power m minus n. So 27 divided by 3 is equal to 9. So let's make it as power and index. 3 to the power 3 divided by 3 to the power 1 is equal to 3 to the power 2, which is 9. 4 divided by 8 will be half. So let's translate it. 2 to the power 2 divided by 2 to the power 3 is equal to 2 to the power minus 1, which is 1 over 2 to the power 1, which is 1 over 2. So exercise number 1.4. Simplify each of expression and write your answer in index form. 5 to the power 2 multiplied to 5 to the power 3 will be 5 to the power 5. 6 to power 4 multiplied by 6 to power 3 is equal to 6 to power 7. Same for C. 10 to the power 4 multiplied by 10 to the power 2 simply will be 10 to the power 6. And finally, 4 to the power 5 multiplied by 4 is equal to 4 to the power 6. That's everything, and goodbye.